Hello everyone, my name is Nguyễn Tấn Hưng, one of authors in this paper. I am senior student majoring in electrical and electronic engineering at Ho Chi Minh City University of Technology and Education. Now, I will present our paper with the name STM32F407 Implementation of unipolar SPWM for three-phase three-level inverter. The author of this paper include Nguyễn Tấn Hưng, Phan Văn Hoàng, Nguyễn Duy Thảo, and Đỗ Đức Trí. Paper ID is 8. Overall, presentation structure consists of 5 sections: introduction, system overview, topology, simulation, and experimental conclusion. At first, I will present the introduction. Nowadays, the multi-level voltage source inverter is a wide range of applications such as photovoltaic system, white power, fuel cell, or hybrid electric vehicle. The T-type inverter is considered as one of promising topology compared to addition inverter family. The comparison with the three-level neutral pole inverter. T-type does not need yield to diodes, its phase and yieldless switching, so it is more compact in size and reducing conduction loss. It's feasible for usage of lower voltage power device. For topology control, we know there are many methods like PD or space vector pull-wide modulation, but it has some limitations, such as PD30 has low modulation index, high TSD, and large common mode voltage. The SPWM is very difficult to decompute and consume microcontroller memory. So, this paper will use the third harmonic injection and modify a phase shift algorithm to improve the above limitation. Currently, DSP widely used in power control with the following advantage: high control pitch, support for SPWM function, but it has some disadvantages such as limited number of SPWM pins, costly, difficult to commercialization. Therefore, the research and application STM32F407 to reflect in this paper. Next session, I will present the system overview. The block diagram consists of STM32F407 board. For regulating spool, isolation, and gate driver used to rotate the circuit. They have two switches, including 5V and 12V, to ensure its operation. The output of driver are distributed to power switch. The inverter has square waveform due to the switching pattern, so get a thin wave signals. The LC filter will yield to reduce harmonic content. In this paper, we use kit STM32F407 to control T-type inverter. Basically, kit STM32F407 ICT6 was used, so I will introduce its appeal. STM32F407 ICT6 microcontroller has 176 pins and its current must be at 168 MHz. It has 14 timers. Its timer can generate up 9 PWM signals at 18.4 MHz for each mark. The timer can work in master-slave mode, changes between timers, and its DMA function, which can automatically transfer data from memory to timer comparator for generating PWM signal without any CPU action. Continue, topology will be drawing. Figure 4 illustrates the structure of the three-phase three-level T-type inverter. Depending on the type of switch, they have different voltage level. For ease of understanding, we consider the sample on a single phase. When switch S1 and S2 which is on, the output voltage is positive VDC half. Similarly, the switches S3 and S4 which is on, the output phase voltage is negative VDC half. Which is S2 and which is S3 which is on, the output phase voltage is 0. By Einstein, we build mathematical equations for electrical circuits for transforming the relationship matrix between the state of the waveform. We get the output phase equation is voltage output equal M times DC times 2 divided by 3, with M modulation index and VC voltage is voltage capacity. Now, let's learn about the SPWM conductivity. In this paper, we study and apply the third harmonic injection and modify the phase shift algorithm. We have reference voltage equation shown on the right side of the ring. By comparing between the reference voltage in the carrier, we get the control signal for each switch. Figure 5 shows on the SPWM for clarity of topology. Figure 6 given on clearly logic circuit entirety. The more detail we can see, the reference voltage were made from the sine wave table by an equation represented. We use the center aligned function in counter mode of microcontroller to make carrier. We make use of the CNT resistor. Then we use the DMA function to compare two signals and use NOT gate, make the signal for the switch. Overview. The proposed solution is quite simple and easy to implement. So, the application on the new hardware is very feasible. The next session is the simulation and experimental. Table 1 shows the parameters of the pole inverter. It applies for simulation and experimental. We can see switching frequency is 10 kHz and using the phase shift, we have the harmonic spectrum of the output voltage is about 10 kHz. So, we choose the filter with parameter as shown in the table to reach the cut-off frequency for the circuit. We use the SinPWM to simulate in this features. We have the following features: the output phase voltage VAC root mean square is about 110. The pole voltage VAO is positive 157 volt, all volt and negative 157 volt. The line to line voltage is 5 level. Output current is 2.9 ampere. In Figure 9, show experimental robotype was built by the authors in Advanced Power Electronics Laboratory in STM32F407. Experimental research showed that similarly to the simulation about 97%. Finally, this paper describes how to release a 3-phase 3-level P-type inverter using a SPWM with third harmonic injection and successfully apply a new control hardware. It has reduced cost in its power system and has commercial potential. Thanks for listening.